In our world, we have classes and objects for those classes. Everything in our world is considered to be an object. For example, people are objects, animals are objects too, minerals are objects. Everything in the world is an object. But what about classes? In our world, we have to differentiate between objects that we are living with. So we must understand that there are classifications, and this is how they get the name and the concept of a class, classification. So we must understand that there are classifications for all of those objects. In our world, we have classifications for objects, and every object must be from some classification. So a class is a way for describing some properties and functionalities or behaviors of a group of objects. In other words, the class is considered to be a template or a blueprint for some objects. Let's look at a house as an example. We can identify some properties that will make a house a house. Just as an example, let us try and define 4 properties. A house will have windows, doors, a roof, and walls. So we can create properties for the house classification that will indicate the number of windows and doors, as well as the type of the roof and the type of the walls for the house. Ultimately, we can then take that blueprint or classification and build as many different objects or houses of that same classification called house. Look at some other house objects we can create. You can clearly see that all house objects will have the same properties, but the value of the properties will be different. We can then go to Java and create the classification called house and have the following properties as variables in the class. As in this picture, you can have some very weird objects of classification house, as long as they have the same properties. Let's go to IntelliJ. Right, back in IntelliJ, I've created a new project called Classes and Objects Example. In my source folder, I created a new package, and the package name is com.example.classes, and I've created one Java file, and this Java file will be my driver class where my main method is. So this is where my application will start. So now let's look at the concept of classes in Java. So in order for me to create a new class, I'm going to go to my package and I'm going to say new Java class. So on the package, so just right click on your package and then say new Java class. So then when we create a new class, you give your class a name, and normally we make our classes all capital letters or uppercase letters of the alphabet. You start with a capital, and then each subsequent word we will also capitalize it. So in our example, we talked about the house object or the house class. So in this case, the house class we said should have 4 properties: number of windows, number of doors, type of roof, and type of wall. So let's quickly create them, and I think you will agree with me that the number of windows as well as the number of doors we can take as normal integers, whereas the type of roof and the type of wall we will look at strings or normal text. So I'm going to say private int number of windows, and I'll also have a private, and I'll explain the private now, private int number of doors, and then I'll also have private string now for the type, sorry, private spelling there, private string, and that will be the type of roof, and we'll also have a private string type of wall. So now when we create a new house object, this object will have the number of windows, the number of doors, the type of the roof, and the type of the wall. Now it's just good programming principle in Java to say that let's go in every class that we create all fields or properties must be private, and then we'll have methods to access them or to change them. So the private keyword here as well as the public keyword there, we call them access specifiers. So that's how do we have access, or how does other classes have access to this class. So in this case, if one of my variables, in this case the properties or the variables, or one of my methods is listed as private, then we will only have access to these members, in this case these variables, in this class. So the private access specifier says nowhere else can you use this variable but in this class where you defined it. Now the class is public, which means that we can use this class in any package outside of this package or inside of this package, any class will have access to it. It's basically publicly available. So the class will be publicly available, but the variables inside it will only be available in the class that we're currently working with. So you'll see the next part that we'll do now is providing the methods, and all of the methods should be public, which means that the class as well as the methods in the class will be available publicly everywhere. So let's start off with some methods that we can have inside of a class. So when we create an object of this class, the object will have these 4 values. So every object that you create will have these exact 4 values, but it could be unique values stored inside of them. So in order for us to create this object, we need what we call a constructor. Constructors will always be public, and it will never return a value, not even void. So you'll say public, and then the constructor will have the exact same name as the class. So this could be the method header for a constructor. So the constructor is the method in your class that's got the same name as your class. And then normally what a constructor does, it sets those 4 values that you've got at the top. If you've got 10 at the top, normally it sets all 10 of them. But we have specific examples where we do not set all of them inside of the constructor, but we can later on use setter methods to set them. So in this case, if you do not provide a constructor at all, so let's say you've got an empty class like this, and you create a new object of type house, then they will automatically, or Java will automatically create a constructor for you. And the constructor will look like the one that we're going to build now. So basically the default constructor, that's the one that Java will provide for you automatically if you do not create a constructor at all. And the default constructor is a constructor that does not accept any arguments like the one we've just defined there. And then basically what it will do, it will make the number of doors equal to 0. So all of your number variables will be set to 0, and all of your object type variables will be set to null. Also your Boolean variables will be set to false. So let's set number of doors and number of windows to 0. We will also set the type of roof to null, and we'll set the type of wall to null. So this is basically what your default constructor will look like. So you can also then basically provide your own version of a default constructor, which we call a no argument constructor. So it's a constructor that accepts no arguments, and then you can set the values to something default there. So this is just an example of how the default constructor of Java would look if we do not provide a constructor at all. So in this case, we provided now a constructor, so the default constructor will not exist, but we'll use the constructor that we created here. Now let's look at another constructor that we can create, and this is a constructor that's used often. And you can see then if I try to create the exact same method again, we'll have a problem. But in Java it is allowed that you can have 2 methods with the exact same name but different parameter types or parameter lists. So in this case we're going to say we're going to accept the number of windows in this method, number of windows. The second argument we will also accept the number of doors. As the third argument we'll accept the type of the roof, and as the last argument there we will accept the type of the wall. So you'll see this is also a constructor because it's got the same name as the class. That one accepts nothing, and this one accepts an int, string, string. So it's 2 different constructors. So if you've got 2 methods with the exact same name but different parameter types or different parameter lists, then Java will allow this, and this is called method overloading. So it's the same method name but different parameter lists. Then we've got method overloading. So in this case I'm overloading the constructor here, and the constructor, remember the constructor method is the method that will construct your object. So in this case we can then set number of windows and number of doors not to 0 but to the values that was passed in here. So I'm going to say number of windows, let's start with doors first, equals number of doors that was passed there. But now you can see this is a bit confusing, because am I talking now about number of doors there, or am I talking of the number of doors there? So just to refer to the object that we will be building here, I'm going to refer to it as using the this keyword. So this dot number of doors refer to the object that will be created, that object's number of doors. And then this number of doors will refer to the one that was passed in to the method. So if you see, if I click on that one, you can see it's selected at the top. Where if I click on this one, it's selected only here. So we're going to set the number of doors to the number of doors, and we're going to say, using the this keyword again, this dot number of windows should be the number of windows that was passed in there. And there you can see the number of windows was passed in. So I'm creating the object now by setting the different properties. All right, so let's set the type of roof as well. So we're going to say this dot type of roof should be the type of roof that was passed in there. And it's this one there. Then also we can say this dot type of wall should be the type of wall that was passed in. So this is then creating a new object of type house or classification house by accepting the number of windows, the number of doors, the type of the roof, and the type of the wall, and then taking all four of those values and setting those values to my variables for my object at the top. So there's two types of constructors then there. There's a no argument constructor that will just set some default values, or you can have a parameterized constructor that accepts, in this case, 4 parameters there of type int, string, and string, and then we set those values as the properties for my new house object. So in your class, there must always be a constructor that constructs your object. So in this case, there's no default constructor here, because the default constructor will only be supplied when you do not supply a constructor at all. And the default constructor will look exactly like this one. But now we've provided one, so there's no default constructor. This we call then the no argument constructor, and I can choose what to set the values to. And then the second constructor here, which is an overloaded constructor now, 2 methods having the same name but different parameter lists, method overloading. So this constructor accepts the 4 values and set them to my object. Now let's look at a few other handy methods that we can use inside of a class, and that we call getter methods and setter methods. So because we defined all of our fields private there, we need to have a public method to change or to get these values out of the object. So in this case, let's start with the getter methods. So the getter methods is basically a method that just returns the value for the specific property. So I'm going to start off, and all of these methods must be public. I'm going to start off with the first one, which is the number of windows. So because number of windows is of type int, that's exactly the value that we will return. We will be returning an integer. And then we'll also start with, and you can see it gives you an indication of how it could look like. And this is actually the one that I want you to use also. So it's, let's say the first one, number of windows. So you'll say get number of windows. Now look at the spelling. We'll normally start off with a get, or lowercase, and then the first value or the first letter of the alphabet of your variable will be capitalized, and then each subsequent word. So I'm going to use it as it is here. This is the correct way of doing it. So I'm going to say public int get number of windows, and then just have nothing in the brackets. Okay, so we're going to say then public int get number of windows. So on my object, I can go and call get number of windows, and it will return the number of windows as I set it. Okay, so in this case, we will just say return number of windows. So it will return the field number of windows. So to get the rest of your getters, it's actually very easy in IntelliJ. So you're going to say right click there, generate, and you're going to say getter. And now you can see there's 3 getters left. There's a getter left for the number of doors, the type of roof, and the type of wall. And all of them work exactly the same way. So you're just going to say OK there, and you can see there's my getter methods. So it just looks a bit different, the layout for your methods, but for the rest it's still the same. Okay, so there's get number of windows that will return the number of windows, which is the first one. There will be a get number of doors, which will return the number of doors. There's also a get type of roof, and you can see now the return type here is of type string, because the type of roof was declared as a string. So it's string type of roof, and that's what this getter method will return back. Also for the type of wall, we'll return a string, but we'll get back the type of wall as a string there. Right, so those are the getter methods, and normally my getter method starts with a get, but remember your name of your method is up to you as programmer. You can choose what your method's name should be, but it's good Java convention to basically use the methods as it is generated here. So you can see it starts with the word get, and then afterwards the first letter of your variable will be capitalized, and then all the subsequent words will also be, or the start of the subsequent words will also be capitalized. So let's start with the setters next. So this is how you get a value, but what if you want to change one of these values inside of an object? For that we use the mutator methods or the setter methods. So setter methods look something like this. Public void, we don't return something because we're changing it. So we're going to say public void, then you start with set, and you can already see it gives you those 4 values of what we've got in this class. So let's start with number of windows. So I'll say set, and then you can see number of windows. So I'll start the N again capitalized. So it's set number of windows, it gives it to you. And then normally what you accept as a value in the parameter list there will be what you want to set your new number of windows to. Now because the number of windows is an integer there, I will use an integer to be set, and you can call the value or the variable there exactly what you want to call it. So we can also call it number of windows if we want to. So we're setting the number of windows. So we're going to take the object that was created. This number of windows will be set to the number of windows that was passed in. So I'm going to say number of windows there. So you can see your setter methods work a lot like your constructor, and what your constructor is doing, it's taking in a specific value and setting that value to the object's value. So we're basically just having them in separate methods now, separate setter methods. So I can then go again for the rest of them. I can just right click and say generate. I want the setters this time. Choose the 3 remaining setters and say OK. And you can see it was generated exactly the same way as I did the very first one. So let's just quickly look at them. There's set number of windows. It accepts the number of windows. Set that number of windows to the number of windows of my object. And then you'll see set number of doors will accept the number of doors as an integer and set my number of doors of the object to the number of doors that was passed in. Also set type of roof. Type of roof is actually a string, so we're going to accept a string as well, type of roof, and then this dot type of roof, which is the object, should be set to the type of roof that was actually passed in. And then the type of wall, which is also a string, will be set to the type of wall of my object. So these are all the setters and the getters methods, as well as the constructors. And that's basically a basic class in Java and how you can create a basic class. So now this class has been created. It's called house, classification house. How do we classify a house? By these 4 properties. And then the main thing of these 4 properties is we need to be able to create an object using those 4 properties. We also need to get every single value of that properties, and also you need to be able to change every single property. And then you've got a basic class. So very important here then, you must have private fields and then public methods to set, change, or to get back the values. So you will not directly refer to the variables at the top or your properties for your class, but you'll refer to the properties by using either a getter or a setter method, or you can use a constructor to set the values right at the start. So remember, always private fields, but we have public methods to access or change those fields. So let's go to the driver class now and see how we can create a new house object. So there's 2 ways of creating this house object now, because we have 2 constructors. we've got a constructor that accepts nothing, and we've got a constructor that accepts 4 values. So let's start with the one that accepts nothing. So we're going to say house equals new house. So remember, in Java, after the new keyword, you are creating a new object. What gets saved into this house variable now? This house variable will hold the memory location of this house object. Okay, so now the house object was created. So let's just use a simple system out print line there. And we can go on that house object, and we're going to call get, let's say, the number of doors, just to print it out to see if it works. So let's run this quickly. And you can see the number of doors will be 0. Why is it 0? Because we said with the constructor that accepts nothing, we will set the number of doors to 0, the number of windows to 0, the type of roof and the type of wall, both of them should go to a null. So on the object, which is, well, basically the reference variable holds a link to the object or an address to the object. So on that object, I'm calling get the number of doors. And the get number of doors there, where's my getters? Get number of doors will return the number of doors that's currently set in the object. So you can see that using this constructor, we've basically set everything to either 0 or to null or to false if it's a Boolean. So then working with it afterwards, you must go and use one of the setters. So I'm going to say house.set the number of doors, and let's set the number of doors to 10. So now if I print it out, calling get number of doors will then get the value of 10. Right, so there you can see it printed out. Okay, so let's not use it like this. Let's go and add some values inside of this house constructor to set the number of windows, the number of doors, the type of the roof, and the type of the wall. So let's first set the number of windows. So let's say this house object will have 10 windows. The second one, the number of doors. Let's say 2 doors, one at the front, one at the back. The type of roof, let's set the type of roof as tiles. And then the last one is the type of wall, and let's set the type of wall to be of type brick. So let me just make this a bit bigger there. So you can see now we used the constructor that accepts 4 values to create the object. So this object will now have 10 windows, 2 doors, tiles as roof, and brick as the type of wall. Right, so now after this object has been created, we can now go to the house object there and put the dot. And you can see there's all the methods that we've got access to. We've got get number of doors, set number of doors, get number of windows. There will also be a set number of windows somewhere. Let's call it set. Set number of doors, set number of windows, set the type of the roof, and set the type of the wall. We can also have the getters there, which will get the number of doors, get the number of windows, get the type of the roof, or get the type of the wall. So let's just do a few of these methods. I'm going to go and say on the house object, go and let's set the number of doors to 3. So we're changing it from a 2 to a 3. And we'll also set, let's just use 2 of the sets. Let's set the type of wall to be plaster. So instead of having a brick wall there, we will now say the type should be plaster. Now when we print it out to the screen, we can then say, let's print out this whole object by saying house. Let's start off with some string first. This is the house object. And then after that, we print out the details for the house. So let's say number of windows. And then we can go use the concatenation operator there, the plus sign there, and we're going to go to the object house again and use the getters now. So the number of windows will be get number of windows, and that will show me the number of windows. So on a new line again, let's get the number of doors. And the number of doors will also be house.get number of doors. Let's use the next one, and then the number or the type of the roof, type of roof. And then the type of the roof you can get by saying house.get type of roof. And then the last one there, the type of wall. And then we're going to use house.get type of wall. And then if we run this, it should be exactly as we have them there. So remember, the object started off with the number of windows 10, the number of doors 2, the type of the roof tiles, and the type of the wall brick. But we changed and set the number of doors to 3 now instead of 2, and we changed the type of wall to be plaster. So you can see the number of windows will still be 10, we didn't change it. The number of doors will be 3 because we changed it. The type of the roof will still be tiles, we didn't change it. But the type of wall, we changed the type of wall to plaster. And this is then how we print out an object. So we'll look at some other methods in the next videos where we can actually use a better way of printing out the whole information about it, but we'll get to that in a later video.